Good morning and good afternoon, everybody. It is great to see how many have joined us here today, and welcome to this Water webinar hosted today by Metasphere. The speaker today is Philip Tomlinson, Commercial Director, EMEA from Metasphere. With a strong background in global sales and export, Philip is an experienced commercial director with a strong background in the water and wastewater industry. Philip's career in the industry spans over 10 years, with responsibility for the management and development of a team of sales managers in the UK and partners within the regional areas of focus such as the UK, Europe, Americas, Middle East and Southeast Asia, achieving organic year-on-year double-digit growth through major domestic contract wins. In his spare time, Philip is not only a keen sportsman, but also passionate about helping to promote and improve mental and emotional well-being in the young people and sits on the board of directors for a charity working with young people, which is superb. We do encourage you to ask plenty of questions at any point during the webinar. Please do type your question to the Q&A box you'll find at the bottom of the screen. At the end of the presentation, we will present your questions and answer as many as possible. It is an absolute pleasure to have Philip with us today, and I would like to warmly welcome him now to take control and begin the session.
Thanks, Martin. Hello, everyone. And welcome to the kind of webinar. So the next half an hour or so, we'll be really talking about the wastewater network opportunities that we're finding here. There's quite a UK focus on this, and I explained some of the reasons for that. But predominantly, we're looking at a real shift in the marketplace and actually some of the drivers for that and how they apply more generally, whether they're globally or regionally, and looking at how those things can be transferred into benefit to us all. I've lost my mouse. Okay, so I think it's really important to kind of really set the scene and to understand why this is important. And without kind of reading kind of verbatim what's on the slide here, and this is a fact from the UN that actually whatever we think we're doing here, we need to do a lot more. This is a kind of global statistic, and anecdotally I can back this up from kind of around the world, and you talk to people about the importance of water and wastewater and what they're focusing on. And actually, I can think of countries I've been where it's like, well, actually, we're still getting everyone connected to the network. We're not even thinking about the beyond 6, 7, 8% of people that are connected to wastewater. And that really underpins the challenge of the mentality of approach to wastewater. And it's only really been in the last couple of years that we've started to see that shift even happen here. As it says there, that in some of the least developed countries, which kind of mirrors my experience, the figure tops 95% of discharge. It's a pretty scary stat. We can all do our bit to improve that, and we'll get into some of the ways that we're looking to address that ourselves. So looking at the UK. So this is a big problem. This is a big problem, as I mentioned, everywhere. This isn't just a big problem for one set of people or one set of clients. It's a problem for everyone. There are a number of bodies, there are a number of trade associations, there are a number of third-party organisations. There's certainly something that's been of interest in the press in the last year, whether on television reports through Panorama. Certainly The Guardian have been very hot on this here in terms of reporting on what's going on against what is perceived to be the reality. So how do we address this? Actually, the comment there, 16% of our waterways in the UK are only 16% are classed as in ecological good health, and it's been that way for 5 years. So actually what we're doing now, is it working? What's changing? Actually, the impact on the environment through, and this is without looking at any analysis of the impact of COVID on those figures. So, excuse me. So actually, we're not quite getting something right yet, but actually there's a lot more being done in the background that hasn't started to impact these figures yet. We'll start to look at some of the variability of factors on that. It's not just about the utilities. This isn't a kind of presentation that's just going to bash the utilities for failing to do what we all think they should be doing. This is something that impacts absolutely everyone. Population, people, industry, companies, we can all play our part and actually need to play our part for this to work. Now, even as someone like me who's worked in this space for a very long time, I actually thought that it had been mandated for quite a long period that all combined sewer overflows, or CSOs as I refer to them more generally, had to be monitored, and that data had to be reported as part of their regulatory compliance. It was reasonably recent that I had people talking to me about the fact they were now being asked to do that. which was a bit of a shock at the time. And I think I had to hide the kind of surprise in my face as I got told that. But actually that for me starts to question some of the statistics in reports like this, where you're talking about 99% of sites. Well, actually, if they're not monitoring all these, how is this known? Is this kind of self-reporting? Is this reliant on people, the public reporting it in? What percentage of this is actually come from known quantitative and actually reportable data? What is true is we're in a much better position than we were 5 years ago from a deployed technology point of view. Actually, I can look back 10 years ago, and then the kind of an exponential curve of what's going on even kind of started then. The disparate kind of levels of coverage across even the UK is kind of plain to see when you start looking at the statistics, whether that's kind of spills per kind of 100,000 kilometre, or actually the number of reported incidents versus those that are highlighted by the EA. So for the focus of kind of the presentation, actually, in terms of rather than looking at things that we as a business don't really work with, such as industrial discharge, we're looking at in-network discharge. So that's generally CSOs, but that can also cover EDMs, manholes, it can cover down to population housing kind of level. It's really quite a broad space. I've mentioned before, this is a global problem. And it's an area that's kind of really in the last kind of year or two really started to ramp up the agenda in a lot of utilities, but also in a lot of environmental regulators. Historically, it's only been addressed through regulatory control and the reality penalty. Now, the penalty for that is only as kind of valid as how hard the stick is that you get beaten with. But we are starting to see the regulators really get teeth and use those teeth to drive positive behaviour. But actually, is that change as enforceable as actually population demand? Are we as a public demanding enough from our providers? It's worth acknowledging that CSOs were designed to operate and do what they're doing. They are doing that. But in terms of actually what's acceptable, particularly here at the moment in the UK, public perception of what's acceptable is really, really changing. It's just not okay for this anymore. It's the general view of the public that nothing should be coming out of these. And that requires huge, huge changes in not only the mentality, but actually the operation of the networks, and requires an investment and design change that is slightly unprecedented. There's an important statistic in the middle of here, which shows actually that there's a combination of factors. It isn't quite as black as white as this, but there was a 30% increase in the number of incidents between 2019 and 20. Now, I said there, the EA kind of acknowledging this to increase monitoring. There's a lot more increased monitoring, as I mentioned previously, but actually 30% more seems a bit of a stretch. There is also coupled to this the change in how these events are reported to the EA, the level they're monitoring, the frequency in which they're transmitting that data, all of which has to be kind of married in to create a rich picture of the actual situation. There are also genuine issues in actually understanding the starting point of the problem. Real conversations along the lines of, well, actually, if we start monitoring that, we're going to know about it and we'll have to do something about it. This isn't just for wastewater. I can think of a lot of conversations that really fall into this category, that it's about exposing the issue. But until you expose the issue, you really don't have a starting point to go from. And at some point, it will become known. So as a kind of recent world example, now I didn't video this, and I didn't take a video of a photo of the CSO because I was trying to keep the location reasonably anonymous. I was in a meeting 10 days ago. I sat outside having a coffee in the morning, waiting for a meeting to start, just taking the view at 8 o'clock in the morning. Kind of looked left from this photo, and there was a CSO continuously discharging into this river whilst I was sat there. This is a river with high tidal impact. So actually the stretch of the river that would have been impacted this is really quite serious. Now, I will state that it had been raining a lot over the preceding weeks to this visit, and it's likely that spill would have been within a consent. But for me, it sits into one of those challenges that was raised in the kind of panorama issue, which is when you put things like 1 minute deadbands on alarms and settings, it seems like nothing when you sat doing something else, waiting for an alarm to come through, you don't notice it. When you're sat watching, just counting the time of how long a minute is, that's an incredibly long time to watch something spill. And that was one of the really powerful messages that came out of that program. Even now, if you just took the second to count to 10, it would feel like a lot of dead space within a presentation like this. That's really linked to getting back to the establishing the base point of what's the worst case scenario. So what we generated this graphic in Metasphere to really look at how we want to understand and represent the changes that we think can and should be made to the networks. It shows a mixture of kind of asset, population impact, actually the fact that quality is a big part of this conversation. And quality of wastewater and quality of discharge is something that's really creeping up the agenda quite quickly at the moment. It also shows discharge, which is kind of one of the points of network that is most focused for this. And that's actually one of the points of it that's been going on for some time, but also of increasing importance. How do we improve this? How do we make it smarter? How do we make it more resilient to demographic change and growing kind of capacity issues? So that's worth at this stage having a kind of an introduction to kind of smart water or digitalization. This is the SWAN or kind of smart water networks, kind of 7 layers kind of diagram. Until pretty recently, this was 5 layers, which is shown by the blue blocks in the middle, of really defining what's involved in smart water. This isn't a kind of an attempt at a buzzword bingo. This is starting to show us actually a connected thinking of actually the intercorrelation of different aspects of our networks, of our businesses, and how we have to work together and see things differently to really enable change. I've sat on a lot of panels and roundtables before, and there's always an interesting question of what's more important, sensors or analytics. There's unsurprisingly some very predictable answers, but I think it has to be true to say that neither can properly function without the other. If you try and do so, where does the value sit? It really becomes very difficult to justify. And some of the areas in here are in different stages of development, and some of the areas are starting to merge and blend into each other, and we'll explore some of those shortly. So talking about merging some of those layers, one of the big things that we've seen, and I imagine a lot of our colleagues from the kind of sensing part of the industry have seen over the last few years, is the move to a merge of that kind of sensing and communication layer. For a number of years now, there's been a lot of workshops, particularly pre-COVID, that talked about the £50 sensor for wastewater. I can certainly think of one of my colleagues talking about throwing tennis balls into the network for the last 15 years and see what happens at the other end. Now, aside from polluting and risk of kind of things like that, the idea was right. The ability to execute at the time just wasn't there. It's technically possible to do that now, but the compromise in terms of operational output, in terms of data and what people want, isn't there yet. And actually, it's not quite that point. And we don't see that point being realized, certainly in the next few years, and possibly not at all, as the demand on the output from this type of instrumentation and network actually is increasing, not decreasing. However, there have been a couple of big shifts in the market, let's acknowledge that, really coming out of the UK predominantly. A number of utilities here are aggressively tendering to do something about this in a way they've never done before. Some are already deploying, and they're going at it in different ways. But the point here is that there's a dramatic 10x factor going on in the market here, whereas there might have been 20,000 points being monitored continuously in the networks across the UK. We actually expect that figure within 2 years, definitely within 3, to be well north of 200,000, possibly pushing 300,000. That's going to require a big shift in a lot of things. And really that's only possible with the emergence of new solutions such as ArtSer, which is ours in this space, which has been designed from the ground up to address some of the challenges for these type of projects that we'll run through shortly. One of the things we've got to address in terms of that merging of layers is the impact of IoT. I mentioned before that actually the tennis ball it wasn't possible. And even 2 years ago, in reality, it wasn't possible. Timing has been right for this, as ever with most things. But the availability of chipset technologies to enable things to actually be scaled down to production, to realize the potential of what we're trying to do, is now happening. And that continued growth and that continued opportunity will be a big driver in the development of the smart sensor market. But it's not about, as I mentioned, with the £50 sensor compromise, it's not just about price. The quality of outputs is still critical. There's 2 comparing graphs on here. These aren't the same sites. They're designed to show a scale of kind of comparison. Obviously, the data on the top is there. You can see your baseline data. But in terms of how you're feeding that into an information analytics alarming platform, you're not going to get great output from that. The old adage of garbage in, garbage out is as true for this as it is for anything else. And a failure at this level causes major repercussions at the data information decision layers as action starts to be taken. Now, whether that's in terms of false positive alarms, as you might see on the top, or actually false negatives, if you start eradicating those spikes and actually miss kind of real life examples of when things are going on. These are things that are really important to get right, but actually you're going to expect to see some of these things when you're looking at mass deployments. The battle will become about on 99% of the sites doing exactly what you expect to do, and how do you manage the decreasing number of those sites that are causing some problems which are or not remediable. There is also a big opportunity around open and shared data. Technology gives us the choice to do something. It doesn't mean we have to do it or that we will do it. The Environment Agency have been really proactive about sharing and publishing their open data sets for many, many years. And there have been a number of people, including the A, who've been actively encouraging utilities to do the same. And we are starting to see that. I'm certainly aware of one utility in the UK who've been openly publishing a wide number of data sets for a number of years now, and absolutely intend to continue. And I've been in conversations with other parties who are actually watching what they're doing and intending to follow that model and do the same. This should be great for all of us, and it certainly should be great for the analytics layers and the ability for kind of other bodies to drive benefit from that data. It's got to be acknowledged, though, this is as much a cultural behavioural shift as it is technology. I mentioned that technology gives us the choice, but it doesn't mean it'll happen. One of the big challenges here is how to achieve something similar through a multi-supplier solution. I'll not sit here and tell you that one solution, so ours in this, will be the silver bullet that solves everything. I don't think that's possible in a single thing. But actually, can you cover the majority of the problems, and actually looking at how you piece together the right solution for that network or that problem that you're trying to challenge. But as soon as you bring multiple solutions into it, you start to have big problems in terms of how you align the data, whether it's just something as simple as naming conventions or terminology, or how you label data points. There's lots of this that needs to be got right. So looking at kind of the big rollouts, what does it mean for mass deployment, and why hasn't it been done before? It needed a big shift. Remembering this is kind of focused on wastewater. The ability to do this and the benefit of doing this actually was really shown in the UK through AMP6. Clean Water drove away with this, and actually that was probably the result of 10 to 15 years of continued and sustained investment and actual focus in the utilities of driving down some of those results. Actually, what we're trying to do in wastewater here in the UK at the moment is achieve the same thing, but in a single app. The challenges are pretty real and pretty significant. The barriers were generally known, and I've got listed the primary ones here. What there wasn't was a will to do something different, because there was a whole range of restrictions, which we kind of talked about historically about what's possible. One of the big drivers, actually, how you move from a 10x kind of increase in kind of monitoring points, was the cost per point. It just wasn't cost effective to scale. In terms of the budgeting kind of process and what was under plan already was restricted for this. Device management systems, the remote management of these devices, and whether it's device health, whether it's firmware, whether it's how you remotely change the operation, the ability to interface to a device once it's in the field is of critical importance for actually the enablement of continued improvement moving forwards. Anything that goes into the field as a kind of one-directional device is going to suffer problems down the line. Whether it's just changing, kind of tightening of alarms and changing process, it becomes an expensive job to change that. I'll talk a lot about intelligent alarms. One of the really important things about deploying a lot of devices is just not creating noise. Utilities already struggle at the moment with the amount of alarms and information that's coming through their control centers. We've got to stop compounding that problem. And there are several ways we can do that. Scalability is something that kind of goes with that. So the scalability affects in a number of ways. One is around alarms. One is about manufacturing. Can we actually get that number of devices into the market? You get into actually installability. Are there that many crews that can do this in this period of time? And actually, things like the ability to move things like AWS or Azure mean that the flexibility required to allow those programs to kind of breathe becomes real and easy, rather than having to worry excuse me, manage an IT program alongside the process. I mentioned installation crews just. Actually, the time and complexity of installation when you're looking at that number of devices is a huge factor. Time is cash on this one, but time is also an end result. One of the things we've looked at is actually one of our early challenges in this process was, well, we want our jetting crews to install this. We don't want it to be complex. We don't want any interaction with the equipment on site. We don't want a laptop. We don't want to have a drill. You start factoring all these things into your decision-making process, you can only resolve this from a ground-up solution. It takes time, it takes belief, and it takes investment, and actually takes being part of the process and understanding the market. But these have all been solved now, in general terms, in the market. What remains? There are still challenges. There is a big, big challenge around site identification and allocation. This is something that's not always in place before programs start, and actually is something that can put a big handbrake on a program very, very quickly. And solutions must complement and integrate with existing monitoring solutions. The requirement to kind of write off existing investments will just halt programs if it's not done properly. There are a few other remaining challenges that are important kind of from this. There's a big piece which is actually identifying where projects, where the deployment is the goal, rather than there being an actual outcome derived kind of goal. This presents real challenges down the line when you're looking at actually, well, what are we getting for this? Was it success? Well, where's the alignment? Where's the golden thread that runs through it all to actually get the outcome? I mentioned there about underinvestment, and I talked earlier about there's been several amps worth of focus on clean water and actually what that's led to here. And that means a lower starting point for wastewater. And the result of that is several approaches coming through here. I talked about actually extending existing programs of work previously, and some very, very large tenders at market at the moment, and tens of thousands of devices. Let's see how quickly we can get these in. This is what we're trying to do. But the result of that is actually that new approaches to business cases, new approaches to investments, are now outside the scope of previous submitted regulatory positions. And that provides a big challenge to the utilities here in terms of how they manage that. I talked about aligning data streams from multiple vendors. It's a really big challenge if this isn't done right at the start. Whether it's naming convention, I talk about timestamps, maintenance, each of these are different for each vendor. There are some efforts in terms of protocols to do this, and actually some of the library kind of process around things like MQTT are designed to kind of clear this. Again, this is about mandating how things work from the start and trying to get as closely aligned as possible. Because if again, it's doing it right at the start might be hard, but going back and doing it later is harder. There's also something that isn't really talked about here, which is about embodied carbon and sustainability. This one kind of came to me a bit last night as I was kind of watching the Earthshot Prize. Actually, we're talking about putting a lot of plastic and a lot of batteries, chemical issues into the networks, but not only producing these, but actually what do we do with them afterwards? And there's a balance here about putting devices in and how we utilize those. So the need to put devices in that have 10 batteries in a device, what's it to do what? Actually, yes, I can understand that when you're looking at isolated points for monitoring the network. But when you're putting 10 devices into a small space, is it really a requirement for them all dialing in that frequently? Or is there a better way of balancing and having alarms by exception through the devices that really gives us what we need whilst protecting the environment? It's worth highlighting that wastewater is a very different marketplace to clean water. And really that, for me, is a result of investment choices over the last 15, 20 years by utilities across the world. Spend profiles for kind of water network technology versus wastewater network technology are hugely, hugely disparate. And if you look at these kind of two sections here, and this is a SWAN template, actually across clean water technology versus wastewater technology, and this doesn't cover everyone, but it's a really good indication of the change, says that it's going to take some time for the wastewater market to become as varied and as balanced as the clean water market currently is. It's worth acknowledging there are very different challenges in the wastewater monitoring space as clean water, whether they're environmental, atmosphere, there's different certification, and as much as the physical locations for monitoring are harder to install, harder to get out, and actually harder to operate. It's worth acknowledging what the role of the regulator is. They have to have both the carrot and the stick. And understanding the balance of incentive and regulation and getting that balance is really, really important. Is there a point actually saying who pays the fines? Where does the risk sit? We've seen various positions on this, from insurance for risk to supplier risk to actually how do you get involved and take as a group solution with the utility in true partnership in working together, because just loading the risk onto the supplier when they're not actually enabling the output is a difficult one, but actually it's one that some might be willing to do in combination. There's also a factor around behaviours. So there's been some very, very public and large fines. Most people know who some of these are, but this isn't about beating utilities. In terms of prosecution from the regulator here, now actually these fines were generally driven by behavioural failures rather than specific spills. Yes, there were repeat spills at site, but it wasn't the spill itself that derived the size of the fine. It's a behaviour issue, which is changeable. Appreciate it doesn't change overnight. Following from that, we've seen, I know particularly certain aspects where alarms are muted when it's raining outside, particularly when it's raining heavily. I know this happens. And it happens because of two things. One is alarm noise. I talked about alarm noise already, and the fact that if you put more devices on there, you create a more alarm noise if you don't have an aligned program around data information. The other one ties to the previous point, which is learned behavior. When you've got operators coming through that see that's what's done around alarms, you just embed that further into the organization and it becomes culture. So we talked about the merging of the sensing communications layer, but actually what we're also starting to see is the merging of the data collection and the information layers. Historically, it's been very, very disparate, and there's been a nice hard line between the two. We're seeing that really graying out as information kind of readily passing between the two, and the entry point for users can sit in either system. It really enables us to be more proactive about problems. In our organization, we talk about the shift from monitoring in order to generate alarms, a very retrospective, reactive type of approach, towards the ability to predict in order to prevent problems, predict to prevent for us. But what you actually get here is time. You gain time to take action to prevent a problem. And if you're purely acting reactively, you can't do that. You don't have time. You're already in negative time. The incident has already happened. All you can do is minimize the impact of it. Now, I appreciate there has to be some alignment with the utilities here in terms of how much time do the utilities need to be able to align work crews and effort to make a difference. Generally, with a lot of analytics platforms, particularly machine learning, you can get up to 3 days, maybe 36 hours. And the closer you get to real time in terms of actually expected or predicted output, the higher the degree of certainty on that output is. So there's aligning an expectation there. And some of that will come through real life experience and building trust in the output of these systems. It's worth acknowledging that analysis has always been done. There's always been a number of highly knowledgeable and skilled people in utilities that have performed analysis of sites to try and understand what the problems are. However, that's pretty labor intensive. I'm sure anyone would agree. What technology is enabling is the ability to handle incredibly complex and large data sets across the whole estate in near real time. We're looking at kind of manipulate or adding 50,000 weather-related points and updating those at 5-minute intervals to ensure that the alarms that come through the system are valid and you're not getting false positives or negatives at the outputs. Because for us, we're looking at the outputs from this. That's the only thing we're really concerned about. And particularly for wastewater, there are 3 listed here. Now, looking at reducing the number of wet weather alarms, talked before about alarm behaviour, is critical. Focusing on assets that shouldn't be spilling, actually, how does this link into maintenance programs? How does this link into ERP systems? With lots and lots of potential side benefits here in terms of how things are managed in terms of the network or the assets. And really the goal is intelligent alarms for clear, informed decisions to enable the utilities to take action to prevent these things happening. So we start to get into some of the aspects, actually some of the technology stacks in here in terms of the machine learning. So what we're doing here is we're combining rainfall, wastewater level data across an area or catchment, or even for isolated assets. And you're looking at you're looking at the data for the asset, you're looking at historic data correlating with that performance against previous types of rainfall to look at patterns of behavior. So you can then get predictive, you get weather fronts coming in, you also get real-time rainfall data from the ground where available. And as a correlation of that, you can look at saying, well, actually, under these conditions, this asset would normally perform in this way. when you can't start to get from that, you get side by side and upstream, downstream assets, you can start to get into a really capable digital twinning in network. And you could actually start to take a step towards kind of proactive pump down and managing the actual quite large capacity in the network, rather than having problems at pinch point in the network where you haven't been able to move that around. There are a number of data sources that are commonly used for this. This is not exhaustive, and we expect this to change almost daily, but certainly as projects start to move forward. I've mentioned already that the goal is to prevent the spill. Surely that is the only goal of utility, the only goal of what we're trying to do here. Everything we're doing is factoring towards that. Looking at reduction of false alarms by over 95%. Actually, when you start looking at kind of 70, 80, 90,000 alarms a day, rather than just being ignored, wouldn't you rather focus on a couple of hundred really important ones across a couple of thousand assets? That gives you some time. That gives you some real kind of area of focus. So again, a bit more detail on some of how some of this works. So again, you're looking at how you align actual asset behaving as expected under those kind of conditions. And actually under that profile, you'd expect it to clear. So don't alarm on that, even if it hits a high, an alarm point at say 80 or 90% capacity, because you know from your weather pattern that that's going to come through and it's going to clear based on the previous kind of level performance of that asset. You then start to get into a couple of areas where it's not that case. So in a dry weather alarm, where you've actually got a building issue in there, or suddenly an emergent issue, which you actually define as probably as a likely blockage, because you either haven't got rainfall coming through to kind of clear the system, or you've got a level that's not driven by localized rainfall. Again, something in its own partial blockage. This can be a combination of the two previous ones, but actually there's a very clear pattern that's usually associated with this that falls outside of a rainfall event. And it's understanding how the system can pick up on that and alert it, usually much earlier than a dry weather event, to enable the right action to be taken. I mentioned right at the start that actually quality of wastewater is a real kind of hot topic at the moment, but something that was barely even being talked about 6 months ago. Conversations in the last 2 weeks looking at actually what will be the cost of monitoring a number of water quality parameters at every discharge point across a utilities network. Now, a number of £1.5 billion was bandied around in that conversation as what they thought it would probably cost. That is a scary number, and that's certainly something that's unbudgeted. But I think that's certainly something where the market is starting to think and where it's starting to go. And if we're getting serious about reducing the impact on our environment and actually utilising the networks we've got in the best way, that has to be part of the thought process. Because there will become a point in time where actually we may need to, or may want to, continue to discharge clean water. I'll use clean water as stormwater. I accept that there are certain parameters within that that come off the road runoffs, which may fall slightly outside this. That's a different conversation for me. But actually, can we guarantee that by discharging this, we're not discharging sewage that's been untreated? Because that's kind of really the focus of the conversation. And we're only going to do that if we know. So actually, there are different conversations about how you monitor that and how actually the different types of technology you might need to do that. You can even then get into actually specific problems around asset health. So septicity around hydrogen sulfide or an oxygen potential, where you're looking at concrete corrosion, where you're looking at actually the buildup of a problem. So from a customer perspective, it becomes odor and you get complaints. There are a number of stages in that, but this impacts two different sets of people in the utilities. So how to get the utility to look across this issue and have a single conversation. Supply chain challenge, but it's something that can be done. There are also areas, coastal areas in particular, have issues around salinity and tidal issues that really cause the network to behave in unusual ways unless you understand those patterns of behavior. Again, it's something that actually is a learned behavior, can be managed through analytics pretty well. There's a big area in here in terms of industrial effluent. It has the ability to kind of really make or break everything. If you remove all the industrial effluent problems, all the conversations previously around plastics change, actually around chemicals that are hitting networks that cause treatment works to go offline, that cause big kind of environmental kind of bio issues. We've got to get on top of that. But again, it's something that is certainly outside of my area of speciality. So it's something that I think is well worth a separate follow-up presentation. For us, this is about walking the talk. We've spent 2.5 years getting to this position where we really kind of felt that this kind of blending of the kind of smart network layers was becoming a realistic platform, and actually something that the market needed. And for us, it's been great that the timing of the market shift has coincided well with that across the year. So what's the goal for this? What are we trying to do? Well, I think we all want zero pollution. I think that goes with the given, really. But actually, certainly for a lot of the utilities, and those, most of us are all invested in utilities in terms of pension holders. We want them to be efficient. We want them to be optimized. We want them to be able to run with what they've got, accepting that it will take time to kind of replace the assets and actually enable the networks to manage without CSOs is a big job. The big shift at the moment to network coverage monitoring, actually that enables the bit around equality, around flow at discharge, which is certainly coming. And my personal view is that the utilities that really get ahead with this during this AMP will get a really good submission response out of PR24 in the UK. Because it enables them to position, they've got a good understanding of the network that they can then invest in their target areas where they're looking purely at flow. As we can see, so a lot of things are going through Parliament at the moment. That's going to become statutory guidance as we get into PR24. I mentioned about quality of discharge. Really, if we want to get a proper understanding of that, a lot more needs to be done in that space. And this is the path, whether we actually want no spills or whether we only want to spill when it's stormwater only. Because if we don't do these two things, we won't know which one it is. There are a number of obvious benefits of getting this right. Network visibility is a big thing at the moment. Utilities start to realize how blind they are to the operations in a lot of the networks. And as their workforces start to shrink and everything becomes more digitized, the reality of that starts to bite and investment cycles continue. Early blockage detection is a critical factor in terms of giving time and the ability to act. That time helps us prevent spills and prevent fines. Good for everyone. When you start looking at holistic network monitoring, and actually the upstream, downstream impact, when you start to really get into kind of good conversations about actually what's the impact of things on true basis of digital twin, you start to look at improved asset performance up and down the kind of network chain. We talked about time earlier, but actually for all of us, for our kids, for our grandkids, actually we want to protect the environment we have now and help move on to a better footing. Certainly for me, a goal that is worth the work. So Martin, I think we're kind of moving on to the next stage of the session.
Many thanks for that. That was absolutely superb. I really appreciate your time. I've got some questions to start with. So the first question is, how can IoT and machine learning analytics be used to improve wastewater network monitoring?
So a couple of the areas that I talked about in the slides are actually the merging of the layers of intelligence. So actually, by merging the sensing communications layer, you're simplifying your point of install, which means you can actually get that kind of mass coverage. But actually, whatever you do, when I'm talking to you to say, you have to have an information analytics layer on the end of this. Whether or not you're looking for us to supply it as part of a solution, you have to have that step one goal. Because really what we don't want you guys to do is just get flooded with the information coming from the field and you have no way of doing anything about this, or actually it becomes such a big problem that data source starts to become a different kind of conversation within the utility.
Thank you very much. Second part to this question, how does IoT and machine learning analytics help utilities to better manage their wastewater networks then?
I think that's about visibility. So I talked about the change of moving from 20,000 kind of monitor points across the UK in terms of in-network to there being 200,000 to 300,000 in the next 2 to 3 years. There's a very clear correlation to that with actually having that number of increasing visible points in the network and being able to operate the network more effectively.
Thank you very much. Another question for you. How best can we achieve an optimized wastewater network that cohesively integrates all smart network devices in real time with immediate visibility?
I think it's going to vary by the client and the stages of development that their process, platform, network is currently at. I think as long as there is awareness at the start of the program of actually what is in place to start with, what should and needs to be kept, what the end goal in terms of what you're trying to achieve are, there will then be a number of kind of sensible step-off point inclusions as to where specialist parties could and should get involved to actually start bringing that together. The other aspect of that I talked about was about naming conventions around time, things like timing of samples and alignment of that, which is really important to ensuring a good outcome.
Thank you very much. Another question for you. Why is IoT technology an advantageous choice for monitoring wastewater levels in a network?
I'm going to assume that's a communications kind of based question. So we've had a reasonably static communications network operating, particularly here, and I think it's true for most of the world, for quite some time. And there are kind of reasonably known challenges around that in terms of ground penetration, areas of coverage. So cellular networks in particular, the kind of 2G, 3G networks, were deployed around population densities. And there are particular challenges around where treatment is done, for example, which tends to be outside of population dense areas because of some of the involvements around what happens near works. So there's a marrying there of your requirement to do something and natural challenges in terms of how you're doing that. We're seeing some really big gains in things like coverage and ground penetrations through some of the cellular IoT technologies. That doesn't preclude some of the non-cellular ones. It's just certainly from some of our choice, because we've had to look at a balance of actually where you can deploy this kind of broadly everywhere, combined with power of output and reliability of connectivity. And actually where you can actually start probably having some balance as well is looking at possibly where you've got satellite critical sites, but you really combine the two then to get the best of both worlds.
Thank you very much. I've got a question here from Carlo. The question is, at WWTP level, is digital twin applied? Which kind of benefit brings? Is it possible to go at equipment level to improve efficiency of the plant?
At a treatment plant level, I've certainly seen examples of where digital twins are applied and used and built. And I will say from right down the basic layer, having a representation set of that kind of asset or piece of equipment at a SCADA layer, to actually having an independent operating model that can take additional inputs and layers, so you can look at what the potential outcome of those scenarios is. They're for me kind of almost two ends of the kind of digital twin scale at the moment. Utilities are in really different spaces when it comes to that. There are some very early adopters. A lot of the consultants are operating quite heavily in that space, particularly when you start getting into the kind of BIM4 stuff and actually how you design plants with that type of mentality and operation from the get-go. Whereas there are places that are several years away from their kind of asset planning cycles that are in reality not going to get to that stage in the next few years.
Thank you very much. I've got a good question here for you, Philip, from Will. If you had to pick one differentiator for the ART sewer product from all previous applicable products, what would it be?
If I had to pick one, at the moment, I would, as a product or a solution, there are probably slightly different answers, right? So at a solution layer, I would say actually at the moment, this is the first kind of true kind of end-to-end solution that's hit the market, from a purpose-built sensor through to platform solution, rather than kind of adapting kind of what's there. And that really gives it a kind of really unique space at the moment. If I was answering from a purely product end of that position, I'll be saying about the simplicity. The no interaction with the device. It takes less than 5 minutes to install on site, and it can be installed by anyone. That is a game changer in terms of costing out kind of project deliverables. But when you marry that conversation to some of my points in the presentation about how do you align data programs, naming conventions, who sits in the responsibility areas for those types of things, the end-to-end connectivity piece becomes quite important.
Thank you very much. Another question for you. Does smart machine learning data analytics help address the challenges that utilities face in managing their wastewater networks?
I would certainly say that it can do. Whether it can solve all the challenges they have in operating their networks is a little unknown, and I think it would be folly to say that it will solve everything. I think there are a huge number of applications that that data analytics and particularly machine learning can and already are, not only improving but kind of helping on. Now, when it comes to network behaviors in terms of looking at patterns of behavior, anything that falls into that camp can actually really well fit into those kind of definitions. If there is an option there, if something is defined to be too big or too varied in terms of the available information that's there, actually that would fall kind of outside of kind of the machine learning aspect. You're then starting to get into the kind of true analytics packages where you've got a lot of data and you're either not quite sure what the exact problem is or you're not quite sure how to address the problem. And you can use these platforms to really kind of challenge your assumptions about where you think the sticking points and the problems are, because it will throw out things that you weren't expecting by looking at kind of cross-silo data sets to really look at the metadata.
Thank you, Philip. Another question for you. This is a CSO question. As you know, CSO pose a risk in having the potential to release untreated wastewater into the environment. How can Metasphere deliver the necessary safeguard to deal with this risk?
I think for us, the reason we chose a qualitative sensor in the sense level as part of an art sewer program is to give you an increased visibility of problems occurring as they build. Whereas historically they've been done either, if you're going down to the simple kind of the switch process, you pick up an event at the point it happens. You then can't protect something from happening. You're only minimizing the impact of that. Whereas you have visibility of a building profile coupled with actually the intelligence in a system say that is a genuine problem. Someone needs to do something about this. Yes, there's an aspect then it's likely over to the client to do something about that to prevent it happening. But actually, could you get to the point saying, well, if we tell you there's a problem, or we don't tell you there's a problem, and there was, do we pay the first fine for you? The commercial options around this, we certainly would have that belief in the output of the systems to have those conversations.
Thank you very much. Next question. Sewer blockages are a major factor in both the flooding of high-risk property and urban areas. What role can smart infrastructure network monitoring play in providing the necessary data to allocate assets in a timeless manner?
There's a couple of questions in there.
What's up to two there, sorry?
No, it's all right. So at a domestic, getting down to a domestic level, to kind of pick that part of the question out, technology has a big part to play in that. Now, part of the benefit of going through kind of a mass deployment piece is rather than just monitoring in your critical discharge points, you actually start monitoring in manholes at a street level. Now, what that enables you to do is pick up localized issues really, really quickly. Now, the limit to this is where you've possibly got FOC issues, and you've got fat soils and greases, where they tend to be at a domestic or a kind of hyper local level. Now you will pick up the downstream impacts of that as you probably get disproportionate flows from different areas of the network, as you kind of raise a job to be investigated there. Domestic level is challenging for that type of technology, but there's certainly areas that we've looked at right to inspection chambers of properties, and we've been deploying kind of units at that level through the course of this year at a couple of utilities in the UK. So they're really looking at what's the complexity of different types of the network, different areas of the network having different kind of patterns of kind of infill from domestic properties, and should they have different different ways of operating those bits of the network, possibly based on times of the year where people might be expected to be home or doing more, or even based on weather conditions again, because the usage of weather conditions, you might relay COVID into that. Actually, are people then going to be in certain areas of kind of property more over a certain time? It's a difficult one to be absolute on, because there are definitely things you can do to help prevent at a domestic level. But I think my point earlier about silver bullets is you need to have a collection of solutions that are targeted at different types of problems.
Thank you very much. Another question for you. how easily can Metasphere products and solutions be calibrated to reflect the changing environmental impact of changing weather patterns that produced unseasonable rainfall and drought?
I think unseasonable rainfall and drought is kind of becoming the de facto standard, isn't it, these days? Certainly there was once in 50-year events are certainly kind of not really that anymore. And that, aside from the fact that that's a major challenge in terms of how you design and plan your areas of operation, I certainly think there's a piece which is actually the combined monitoring of those different inputs becomes really important. Yes, there will be areas, so you get things like bands of tolerances on analytics and kind of machine learning outputs. So you get a kind of tracking performance, you can kind of get your plus minus behaviors. Actually, when you see things moving out of that tolerance of normal operation, you can then start correlate that to an abnormal weather event, whether wet or dry.
Okay, thank you very much. Another question for you, Philip. Utilizing the capabilities that IoT, AL, and ML bring to smart water networks, how compatible are Metasphere's products and solutions in integrating with legacy systems that would impact upon their operational capability?
So certainly historically, one of our USPs as a business has been kind of interoperability, and actually how to have particularly field equipment integrate to other vendors' systems, whether that's competitors, whether that's utilities' own systems. That's certainly been a USP of ours over the years. Now that certainly changes as you get into mass deployment. It doesn't mean it goes away, but actually the initial focus changes from actually you've still got to manage these devices in the field, so you need a way of doing that. But actually, if a lot of the utilities want to have integrated data at a macro level, so they don't necessarily want to be worrying about managing the config or the firmware on a particular device. They might have it as part of service, and they might have some of their own engineers looking at that. But actually, as a data integration point, they're looking at that at an overall network or an overall business layer. And these are quite often come into an above telemetry or above SCADA layer, and it's quite often called data lakes is a really commonly kind of thrown around term for this at the moment. But they're platforms of data ingestion that enable the utilities to take data from a huge variety of sources, much more than they ever have before. And again, you start to actually watch the predominant use for that is start looking at multiple data sources to solve the same problem.
Thank you very much. Another for you. What is unique about Metasphere's solution?
Different or the same one as before?
Perfect.
I think we had a very similar question before, that was all.
Sorry. Next question. Would you say then that Art Sewer offers a sustainable approach to help protect the environment?
That's certainly been part of our core part of our process. So on one of the slides, the environmental impact and sustainability of it is part of our purpose. It's embedded in our values. No spills is part of our brand promise. This is part of the fabric of the organization. And for us, where that starts to impact into a device layer is actually how can you optimize, how can you get the best out of a device that's going to a part of the network without just kind of throwing kind of polluting products out there. It's one of those things that you've got to find a balance and designing something down to a really specific purpose to actually how can we optimize that using the least amount of resource really for me fits the bill for that one. Absolutely.
Thank you very much. Okay, Philip, final question for you, and it's a two-parter. So the first part, in terms of operational visibility, how does Pallet rank against your competitor for a web-hosted telemetry SaaS product?
For web-hosted data, I think there is a core set of requirements, shall we say, and this is kind of true against kind of most products in kind of most markets, but there's a core set of requirements that all the kind of platforms and vendors satisfy at a level. Whether that's looking at things like operational trend data, whether it's kind of raw data that can then be plotted out as a graph, whether you're looking at kind of functionality in terms of viewing, whether it's mapping, looking at alarms, events, anything like that. I think there is a general level of positioning across the market, which is very, very common on this. We took a slightly different approach with ours that from our experience as a telemetry systems provider over the kind of 35 years, is we knew there were bigger problems looking at actually large estates of devices rather than looking at starting straight at a single site level. You can get down to that, but actually a lot of users are looking actually, where are my problems? If I start at here and then drill down, it's much easier to get to a problem rather than worrying at a site level and then going back up to try and see if that's a broader perspective. I think that's just it is a perspective thing rather than as a kind of design thing. And I think it comes from actually our background as a systems vendor rather than coming as a background from a data log company that are going up into the cloud.
Thank you very much. And the second part, and what are the key differentiators and that differentiates your network monitoring products and services apart in the smart water city IoT market of the future?
Should we have another webinar? But no, the smart city IoT kind of marketplace of the future is going to become, I think in my view, I talked in the presentation about the fact that there's a shift in wastewater in terms of actually, this is what's going to be expected in kind of 3, 4, 5 years time. And I think that position, there's a couple of aspects to it. One is the ability of platforms to integrate across multiple vendors' devices and bring that up into a single view of the world. That's kind of incredibly important. That's certainly the shift that's kind of going on. From a device perspective, you've got the recognition of split requirements. Design devices down to really targeted applications to really enable the kind of stuff talked about today is incredibly important. But actually the ability to integrate with a wide range of equipment and systems, so you're not kind of, so you're being open about the process, I think is probably the key for us. And you really need to work into a collective environment, and whether that's working with our competitors, we've done that on some jobs before, whether that's working with a broader supply chain from kind of consultants down through tier ones, down through kind of micro partners, down to other instrumentation partners. You've got to be able, you're going to have to more and more find your piece in that puzzle rather than trying to own the puzzle. That's kind of very much.
Absolutely superb. Philip, just before I wrap up, I just want to say many thanks for the webinar today. Absolutely superb presentation and Q&A session. We really do appreciate your time. Thank you very much.
Thank you, Mark.
Ladies and gentlemen, once again, I'd like to say a big thank you to Philip from Metasphere for an excellent presentation and Q&A session today. Today's webinar will be on demand for you to rewatch as well. Thank you to everybody for attending, and we do look forward to seeing you all at our next WeWater webinar. Philip, have a lovely week. All the best. Thank you and goodbye.
Thank you.